Thank you so much, everyone, for coming. So just want to make sure you're in the right room. This is all around the clean energy workforce. Yeah. So we're going to be talking about that. We've got a couple of talks, and then we're going to have a couple of panel discussions, which I think are always slightly more interesting and interactive. So, but before we start, I would like to show my respects and acknowledge the Bedegal people, who are the traditional custodians of the land on which this event takes place, and to elders past and present, and anyone First Nations in the room as well. I'm going to run through a very quick agenda. We're going to have a welcome with John. So he's going to talk very briefly about the Digital Grid Futures Institute, what we do, and a little bit about the focus areas for what we're investing in for next year. So just a bit of a who we are. And then we're going to get on to the juicy stuff, which I'm really excited about. So Hua Chai, who is over there, is going to be talking about a really exciting project that we've started to seed this year. And it's all around how we can map career pathways within the energy transition. So I'm really excited to hear about that. Then we're going to talk about the student energy. We're going to hear from a first final year and graduate student from two ends of the spectrum, from business and finance, and also from renewable energy engineering, and just around the student energy initiative that we recently launched, or they've recently launched here at UNSW, which is Australia's first. Then we're going to have a chat amongst them, and John is actually going to ask a few questions about Gen Z and young folk and how we engage them. We're then going to have, and straight after that, we'll have some Q&A. We're going to have another panel then to talk about the industry perspective and also an international flavour and perspective of what's happening overseas. And that's going to be with Danny Kennedy, Jacqueline Crawshaw, Rick Eisbeclean from Microsoft, and myself will be moderating. And then we'll have networking and refreshments immediately afterwards until 5:30, when we'll be ejected out of this room. John, shall I hand over to you?
Well, thank you all from myself for coming, particularly the members of the advisory board for the Digital Grid Futures Institute, and those of you who've come to join the panels, and those of you who've come as students, and those of you who've come from far and wide to be here. I do thank you all for attending. This is an event by the Digital Grid Futures Institute to set the scene a little bit. The Digital Grid Futures Institute is an institute that was established by the University of New South Wales as part of its 2025 strategy. Around about 7 years ago now, it was first mooted at a time when the university was doing particularly well in terms of revenue. And the university injected around about $6.5 million into each of the 4 Futures Institutes, of which the DGFI is one. And to give you an idea of how well we think we've done a job, we've got a bit of a snapshot here. The Digital Grid Futures Institute primarily funds seed-funded grants to staff, generally academic staff within the university. And we track how those projects go. They're not necessarily just about research. They're about trying to translate research outcomes from the lab into real impact, which is obviously one of the key differentiators as we move into the future of higher education. So our last look at all the things we've done, we've got about 200 members. You might ask, what is a member? A member is a member of staff who have got at least $1 from the Digital Grid Futures Institute, okay? Generally speaking, it's much more than that, but that gives you at least some way of understanding how we arrive at that number. The bottom graph on the left kind of shows how the funding has been distributed on a time basis, and you can see that in the first few years, we spent quite a lot of money in relation to our total budget. That was before I became a director. I think I was put in the directorship because I'm Scottish, and therefore I maybe look after the money a little bit better. But but I have still managed to get it all spent. And hopefully you can see it's spread around a little bit more. So the colors are identifying the different faculties that we've invested in. And in fact, one of the great things I enjoy about this particular job is being able to find out what all the other people in all the other faculties are doing that is relative to the energy transition. And it's kind of built a mantra in my head, which is there's not one academic on campus that can't do something useful in this area, which is pivotal for me as a very narrow academic whose focus is on things like power converters, inverters, electrification. In fact, already that's a huge area, but I do have a very narrow view of all the things that are important, or at least I did before I took this job on. And I've had some fantastic conversations with people well beyond the Faculty of Engineering, which has helped build an understanding in my mind of some of the challenges that are probably bigger than the technical challenges, if I'm being honest, which I always am. Schools and centres, we now tapped into 41 individual faculties or centres of the university, just to give you another idea of the scale of and the breadth of the things that we do. And the bottom right-hand diagram is kind of trying to capture the things that generally the university is interested in, and that is how many publications, how many papers, how many PhD completions, how many dollars have we leveraged as part of the Digital Grid Futures Institute? And it turns out, without really trying, we've done a really good job. We've managed to get about a 10-to-1 ratio between funding and leveraging, which is fabulous. And we're in the stage now where we are bidding for our next 5 years of life. And our hope is that there's enough on this snapshot to convince the university that, at least for this Futures Institute, there's a really good life in front of it. And I think we'd probably all agree the energy transition isn't going to be over next week or next year or next decade. It's going to be going on for decades and decades, which is partly why we're here. And I know, Sharon, you only gave me 10 minutes to talk. I'm doing my best to keep up with that. Okay, so this is my version of the digital grid. It's full of technologies, things like inverters, storage, microgrids, transmission systems, all the things that keep me awake at night and get me up in the morning and out of bed, because I really do love all this stuff. But of course, as I said, that's quite a narrow view of life. And what we've done in the last year as the Digital Grid Futures Institute is we've tried to really form a better understanding of how all that technology then maps into a whole range of other areas and other clusters that support the energy transition, and this notion of a digital grid of the future. And I'm not expecting you to read the writing on each of those little bits and each of those little clusters, because it's not the area that really matters. It's the breadth of those areas that bring this energy transition into the focus for all of us. So we took those little clusters of activity, and all being well, they would change color, but they're not going to play ball today. So we've kind of got a traffic light system: red, DGFI yellow, which is the color up at the top right. That's I think we're going to put. Oh, that was the best one in the pack. That was the one that made it all worthwhile. Okay, so there's red. Some of these clusters are colored red to indicate that we, as the DGFI, recognize it's a key area, but we've got to invest in it. Some of them are green, where we've invested enough and they seem to be kind of growing their own life, and we don't think we necessarily need to invest in those areas. Then there's the DGFI yellow, which are the areas that we've kind of invested in over the last couple of years. And we're now kind of following those up and keeping them going and hoping that they make a success of those areas. And then we can bring them all together and solve this problem. Makes it sound really simple, doesn't it? Solve this big issue of what we have to do to make this energy transition. Any questions? Okay, sorry, I thought it was a lecture there. Right, so one of the topics we're going to be covering today is partly about the talent pipeline and how we make it happen. And there's push factors and there's pull factors. And okay, this is a little bit colloquial in a sense because we're just looking at the Australian context, but that's actually really important for many reasons. If we look at the number of high school children doing their HSE annually, it's about 68,000. It's quite a healthy number. Number of students doing enough maths to get into an engineering degree is one way of putting it. Best case is 12,000. The average need for engineering graduates is around about 15,000. Now, that means there's not enough high school children doing enough maths, and assuming they all decided to do engineering and all finished an engineering degree and ended up doing engineering, there still wouldn't be enough per year to satisfy what we think will be the need for engineers into the future. So we have a bit of a challenge on our hands, and the workforce challenge is as big as the technical challenge in my head. And we need to find ways of generating more engineers that can come to Australia and can do a useful job in helping us achieve this transition. And one of the talks we'll have today from Hua really is digging deep into those challenges and how we try to solve them. And then part of the story is how we embrace and engage students at university and help them understand the part they can play in this transition. So we have two of our students from the Student Energy chapter here at UNSW, which I think is the first in Australia, Sharon? Yep, so we're really pleased to have them here. And they will talk a little bit about the great work they're doing in helping everyone other than engineers really understand where they can fit, because I think that's a really important part of what we should be doing as a university. Okay. I thought I was finished. I'm not. Probably the most Great. So this year we're having our seed funding round at the end of the year before the seed funding will happen. Now there's a reason for that. At the end of 2025, we must have spent all of what we were given up until the end of 2025 across that whole $6.5 million. There's not actually a great deal left, but there's about as much as there has been in the last couple of years. And what I've really wanted to do for a number of years is not just help academics and researchers access some of these funds. I'm aware that there are a number of professional staff who can also contribute into what the university does in translating things. So in my head, it's people like Subhash, who works in my workshop and makes things. We've got the Technology Translation Squad here, who have many, many years of experience of working in industry and now really developing some of that translational experience. And I think all these people have something to offer. And in my head, that means the DGFI should be reaching out to them and trying to help them recognize what it is they can do and help them achieve something useful with impact. So that, for me, is really the big focus of the next year. But it's not the only focus. We're equally as interested in PhD students coming along, having a chat and putting something together, because let's face it, if you're a PhD student and you've just finished your PhD, surely you've just done something that no one else has ever done, and you'd like to think that should have some value somewhere in this world of ours, and hopefully in the energy transition, which then means the DGFI can help fund some extension work on that, which might be protecting IP, might be developing a prototype, that type of thing, something that pushes research out of the labs and into some useful form of impact. Have I missed anything, Sharon? Okay. Yes, okay. I'll maybe not read all these out. I'll let you just ponder for a few moments. We have interesting anecdotes about all these areas. Cybersecurity is one of those. There was an inverter manufacturer who was making inverters that had a security code that enabled someone external to the inverter to change some of the operating parameters. And they had a 4-digit PIN number that you could not change. The consequence of that is that anyone who had any real hacking capability had the potential to hack into that inverter and change its operating parameters. And if that inverter happened to represent a gigawatt of distributed energy on the network, you can see it's very quickly and easily you can invest in a set of technologies that you suddenly wish you hadn't done, or that you paid a little bit of attention to this detail before you started spending lots of dollars on it. Okay, I do have other anecdotes, but I'll maybe save those for the drinks between 4:30 and 5:30. And on that, I will finish my little spiel for now, and I have the great pleasure of introducing Dr. Chow Hao. Okay, I didn't get a name tag, by the way. Right. Okay, sorry, doctor. The floor is yours, and thank you.